So we're going to work with equations that have fractions in them. And the idea is we can multiply by whatever we want on both sides of the equation as long as it's not zero. So if you have something like a equals b, you're allowed to multiply by some real number and keep the equation as long as c doesn't equal zero, okay? So that's the idea. So what we're going to do is we're going to find the LCM, or the LCD, the least common denominator, and that's the number that we're going to multiply on both sides of the equation. So let's look at our example here. We have 1/4 x plus 1/2 equals 5/8. So I look at the denominators, 4, 2, and 8, and I decide what the LCD is, or the LCM, and of those denominators, and it's 8, right? 4 goes into 8, 2 goes into 8, 8 goes into 8. You want to use the smallest number that you can. It'll be easier. So what we're going to do is we're going to multiply the left-hand side by 8, and we're going to multiply the right-hand side by 8. We have to multiply both sides to keep the two sides equivalent. Okay, so now we distribute. So we have 8 times 1/4 x plus 8 times 1/2. You can put 8 over 1 if it's easier for you. And then we have on the right-hand side 5 over 8 times 8. Well, the idea is now all the denominators are going to cancel out. So 4 goes into 8, 2. So you're going to get 2 times 1, which is 2x, plus 2 goes into 8 4 times, plus 4. And then these 8s cancel, so we get 5 on the right-hand side. Now we don't have any more denominators, and that's the whole idea is we say we are clearing the fractions. We get rid of the fractions, and we can do that because it's an equation. So that's why we're allowed to multiply both sides by the LCD. Okay, now it's just an equation to solve. We're going to subtract 4 from both sides and get 2x equals 1. And then divide both sides by 2. And so we get, let's see if I have a little more room. Oh, x equals 1/2. Okay, so that's the idea of clearing the fractions. So we'll go to our next example here, 10. So we have 7 equals 1/2 x plus 3/4 x minus 2/3 x. So look at the denominators, 2, 4, and 3. What's the smallest number that they'll all go into? I believe it's 12. So the LCD, I always like to write it down, is 12. So we're going to multiply 7 by 12, and we'll multiply the 1/2 x plus 3/4 x minus 2/3 x. We'll multiply all of those, each of those, by 12. Now, yeah, okay, so 7 times 12 is going to be what, 84? And then you're going to have to distribute. So the 12 times 1/2, that's going to make it 6x. The 12 times 3/4 x, which is going to be 9x. Now you could write those out like we did on the last problem. Just go 12 times 3/4. You could do it off to the side. Or within the problem. And then minus, now 3 goes into 12, 4 times 2 is 8, 8x. And so now I have gotten rid of the fractions. I've cleared the fractions out. So I have 84. On the right-hand side, those are like terms we can combine. So we're going to get 7x. Yeah. And divide both sides by 7. And it turns out this time we're getting x equals 12. So x equals 12. Okay, let's go to the next example. It's a little bit different. You'll notice that there's distributing. We could distribute first, but I'm not going to. I'm going to look at the 1/5 and the 1/4, and I'm going to multiply both sides by 20. So the LCD is going to be 20. So I'm going to go 20 times 1/5 times m minus 3. And I'm going to hold off on that distributing. And then on the right-hand side, it's going to be 20 times 1/4 times m minus 7. Well, our properties of associative property says that we can do that 20 times 1/2, or 20 times 1/5. So I'm going to multiply those. 5 goes into 24 times, and I get that. So 5 goes into 24 times. And then on the other side, 4 goes into 25 times. And so I have 5 times m minus 7. And so now I don't have to worry about distributing the fraction, because when I multiplied by 20, that cleared the fractions out. Now I can do this distributing. I have integers, and it'll be a little bit easier. So I have 4m minus 12 equals 5m minus 35. Okay, so I follow the rules for solving an equation. I want to get the variable terms on one side, so I'm going to subtract 4m. I have negative 12 equals m minus 35. I'm going to add 35. And what do I get? M. And on this side I get 23. Okay, so m equals 23. And you can check the answer. Okay, so we've got one more example, I think. That is not there. Okay. So I see denominators. I see that the LCD is going to be 4. That would be the least common denominator for the denominators that I see. Now when I multiply by both sides by 4, it's going to look like this. Oh, that parenthesis should be big. Okay. On the right-hand side, I have to multiply 4 times this first expression, the part that's over 2, and then I also have to multiply 4 times that 1. So it's going to be 4 times 2x plus 3, no, that's okay, over 2, plus 4 times 1. And then on the right-hand side, well, there's nothing really to distribute. That's all one expression. So that 4 is going to cancel with that 4. And I just have 4x plus 3. Now, on the left, back to the left, 2 goes into 4 2 times. So I have 2 times 2x plus 3 plus, and then 4 times 1 is 4. Okay, now the fractions are gone. Yay. And I have a little distributing, though, to do, but from here we follow the same steps that we've been doing. So 2 times 2x and 2 times 3. So 4x plus 6 plus 4 equals 4x plus 3. I have a sneaking suspicion about this. Okay, so on the left, I get 4x plus 10, and on the right, I get 4x plus 3. Okay. That should tell you something. This is not going to be a conditional equation. This is going to be a contradiction. 4x plus 10 can't equal 4x plus 3. So this is a contradiction. I'm going to write it out here. Contradiction. So we know that the solution is going to be the empty set. But let's say you didn't see that, and you subtracted 4x, and then you said, oh, 10 equals 3. At that point, you should realize, oh, I don't have an x anymore, so it's not conditional. Either it means the equation, whether it's true or false, it's not dependent on the value of x. And it turns out this equation is always going to be false. So the solution, we still have to put the solution. It's not enough to say that it's false or that it's a contradiction. We have to say the solution is the empty set. Okay, sometimes they'll say no solution as well.